Hi everyone, Mary here, and we are going to do an example problem for kinematics, and here is the situation. A woman and her dog are out for a morning run to the river. The river is 4 kilometers away. The woman runs at a constant speed of 2.5 meters per second in a straight line. Her dog is unleashed and runs back and forth at 4.5 meters per second between his owner and the river, until the woman actually reaches the river. I want to know what's the total distance run by the dog. Okay, as we do this, we're going to start out with a little bit of a sketch, because sketches to me make my life a little easier. I can kind of picture what's going on. So here's my little lady out running, and way down a long distance down the way is a river, and with her, I'm going to change pens here, she has a little dog. And so here's her little dog, and her dog is all happy and excited and having a good time and running from the woman to the river, and back again, and back again, and back again. So I want to know what's the total distance run by the dog. And the challenge is, as the lady moves forward, the distance the dog is running back and forth keeps continuously changing. How do you handle a problem like this? Well, if you've got two things in motion, you begin by actually putting down 2 columns of information. You write down what you know. So first off, I'm going to talk about the lady. Now, the lady is running at a constant speed of 4.5 meters per second in a straight line. So that actually means that's her velocity, because it's a straight line. So she is going at 2.5 meters per second is her constant velocity. I'm not putting a little hat over it because it's not average, it's constant. She's running to the river, which is 4 kilometers away, and that is, kilometers is a displacement, so I'm going to put that down as the displacement that she's traveling. That's all I know about the woman. Now let's talk about the dog. The dog is running at a speed of 2.50 meters per second, and I want to know how far is the dog traveling. Now that's going to be a distance, because his direction is constantly changing back and forth and back and forth. I also don't know how much time the dog is going to take for the journey. And I don't know how much time the woman is going to take for the journey. But here's the cool thing I do know. I know that when the woman gets to the river, the dog is going to stop running back and forth and back and forth and back and forth. So the variable that the lady and the dog share is time. Time is actually going to be the same for both the woman and the dog. So this is a 2-step problem. First thing I'm going to do is use the information about the woman and calculate time. Once I have time, I can put it into this pile of data, and I can actually calculate the distance traveled by the dog. So let's go ahead and do that. So the first thing I'm going to do is I'm going to find the time for the lady to actually do her running. Now, we don't have an awful lot of physics equations so far, and the reason I like writing down my variables like this is it helps me choose equations. Which equation do we have that has velocity, displacement, and time? Well, we only have one. Velocity is change in displacement over change in time. And I'm solving for time, so I've got to do a little algebra here to actually solve for time. So I'm going to change ink colors, so hopefully you can follow me. If I want time to actually be on the top, first thing I'm going to do is multiply both sides by time. Algebraically, if you do the same thing on both sides of an equation, it does not change the value of the equality. And time divided by itself, time, that's going to cancel. So now I've got time times velocity is going to equal my change in displacement. I'm not quite done yet. And the reason is, now what I have to do, I want time by itself, and I am going to get rid of velocity. So to get time alone, I'm going to divide both sides by velocity. If you do something on one side of an equation, you have to do it on this other side. And that also means that these velocities are going to cancel each other, and I'm going to end up with time is displacement divided by velocity. Now, if you are good at algebra, and I am good at algebra, I do my algebra every single time I need it. If you are not good at algebra, be your own best friend and write down different variations of these equations when we figure them out together. Like I said, you have to be your own best friend and do that as you need to. Okay, I've got my equation. I'm going to put my numbers in. So time is going to be the change in displacement 4 kilometers divided by velocity 2.5 meters per second. I have a problem. Do you see my problem? Yeah, my problem is one of my units is meters per second and the other one is kilometers. You cannot put both meters and kilometers into the same problem. When in doubt in physics, go back to the MKS set of units. So I'm going to convert kilometers to meters. And one of the ways we can do it is with the number line. The other way is by setting up a simple TIE fighter that says I'm going to get rid of kilometers and keep meters. And there's 1,000 meters in a kilometer, and 4 kilometers then will be equal to 4,000 meters. Now I'll actually have the numbers and I can go back and put them in my problem. So displacement over velocity, this is going to be 4,000 meters divided by my velocity, 2.5 meters per second. And when I do that, time is going to end up being 1,600 seconds. Now, before we continue the problem, let's take a look and see where the heck did seconds come from out of this mess right here. Please get used to using your units as helpers. They will actually help determine if you did your algebra correctly. Meters divided by meters per second. Meters divided by meters per second. If you remember long ago and far away when you learned how to multiply and divide fractions, to divide by a fraction, you multiply by the inverse. You turn this over. So this is going to be seconds divided by meters. Meters cancel meters, and I'm going to end up with seconds, which is a time unit. I'm looking for time, so hallelujah, that's a good thing. I got time units because I wanted time. Now, am I done with the problem? I'm not, because what do I care about? What's the distance the dog ran? Okay. Now remember we said the dog's going to stop moving when the woman stops moving. And how long is it going to take her to get to the river? Well, 1,600 seconds. So now that I have this, I now know the dog's time is 1,600 seconds, and I'm going to look for displacement. So I'm going to use my other little rate time distance equation. Speed is displacement change in distance divided by time, and I'm looking for distance. So I've got to do a little algebra and solve for distance. I'm going to change my ink color. I want to get distance alone, so I'm going to multiply both sides by time. T is going to cancel T. Distance will be equal to speed times time, or the distance in this case is going to be 2.5 meters per second times 1,600 seconds. Seconds are on the top, seconds are on the bottom. Those are going to cancel. I'm going to get a total answer of 7,200 meters, and that's the distance the dog traveled. Alrighty, lots of good stuff going on here, and we will see you next time. Bye-bye.